All right, today we're going to talk about how to solve a solution stoichiometry problem. So these are double displacement reactions. They're happening in aqueous, and we're producing a solid precipitate. In this question, we're wondering how many grams of aluminum hydroxide, that's this compound here, will be formed from 55 milliliters of a 1.5 molar solution of potassium hydroxide. So we need to relate two different things in the balanced equation. That's when we know we're going to have to use mole ratio. In order to use our mole ratio and relate those two different things in the balanced equation, we must be in moles. Based on what's given to us in the problem, we don't have moles, but we could obtain moles by using our molarity equation. All right, so my molarity equation, molarity is equal to moles over liters. Moles is equal to molarity times liters. So in the given information there, I do have 55 milliliters and 1.50 molar. So I have molar, I have the molarity, but I do not have liters currently. You should know that there are 1,000 milliliters for every 1 liter. So if I have 55 milliliters, and there are 1,000 milliliters in 1 liter, I have 0.055 liters. Now I'm able to use those numbers and plug them into my equation to solve for moles. So we have moles is equal to molarity times liters. My molarity was 1.5 molar. I'm going to multiply that by liters, which is 0.055 liters. When I do that, I get 0.0825 moles of potassium hydroxide. So now that we have moles of potassium hydroxide, we can relate it to the aluminum hydroxide using the balanced equation, using that molar relationship of 6 to 2. So I'm going to start my problem with 0.0825 moles of KOH. And I know that for every 6 moles of KOH, I put my KOH on the bottom so that that unit cancels out. For every 6 moles of KOH, I will produce 2 moles of product, AlOH3. And then am I done? Well, the problem asks for grams of aluminum hydroxide. If I stop my problem right here, I'm actually going to end up in moles. So I do have one more step. I know the molar mass of aluminum hydroxide will allow me to convert this from moles to grams. The molar mass of aluminum hydroxide is 78 grams. That's a big formula. All right, so now my moles cancels out, and I'm going to end up with grams of aluminum hydroxide, which is what I wanted. When I multiply everything in the numerator and divide by everything in the denominator, I get 2.15 grams of aluminum hydroxide. So just to review, we wanted to find the grams of our product, the grams of precipitate, from a solution. We had some potassium hydroxide dissolved in solution. We had 55 milliliters of it, and it was 1.5 molar. Using that information, we were able to find the moles of potassium hydroxide, which was 0.0825. Then from moles of potassium hydroxide, we were able to use the mole ratio to relate it to the aluminum hydroxide, which was the solid. And then from our moles, we're able to go to grams using molar mass in the periodic table for our final answer here of 2.15 grams of aluminum hydroxide.